Hey, hi everyone. This is Team Astromans and I am Sanjay Maladi. Today I am going to present my hackathon project, which is Datasense. So, Datasense is basically an fine-tuned LLM from Gemma 4 E2B model, which is targeting a problem of solving data-related tasks, analytics, visualization, and any other tasks in a simpler way for the user to solve it, and also in a lower compute, so that we don't need high-end GPUs to run this model. So we are targeting two pain points at the same time. So this project is intended to solve any real data science data related problems in real time. So how it works is basically, as I told you, it's a fine-tuned version of Java for E2B, which is fine-tuned to write any data analytical codes, and it is fine-tuned in such a way that it tries until it gets the answer. It won't stop until it won't hallucinate or it won't make up data. So some notable numbers, as you can see on my left, are 213x in risk model speed up. We saw a jump of like 213x in time, and rolling we saw 69x, and merge we saw 55x. So going ahead, like you can see, we have chosen an L4 GPU for all the GPU related tasks, and a normal CPU, both of them situated in Modal, and both of them are using a similar inference provider, so that we don't face any other issues in the calculation. So as you can see, our main USPs being the agentic loop part and the self-healing part, and also the LLM summarization, and the main model itself, the core model itself is our USP, that how it works and how it writes the code. So as you can see, once the let's go a bit down higher. So how the once the user writes the query, we ask the agent to try to solve the problem. It will start thinking in loops. It will try to solve the code. If it gets an error, it will send that error again, and it will try to fix that error again, and it will fix until it has the perfect code, and it runs it and checks the answer is right. Until then, it tries to solve it. So that's the main USP of the model. And yeah, also we did a lot of things such that the model itself becomes faster. Last time we implemented just cuDF and cuML in the model itself to make it faster. Now we have also implemented MTP for speculative decoding and give us faster token prediction. And we have integrated the model to be in 4-bit right now, so that the model can take a bit more VRAM but perform faster. We have also enabled KV cache, such that if a user asks the questions again and again, we have some kind of data backend, so that it runs again and again. So that's how it is done. And you can see the tech stack being used here. From NVIDIA, we are using cuDF and cuML. That's there from before as well. From Google Cloud, we are using the data sets, BigQuery as a whole, and from LLM infrastructures, as I told you, Modal to host the model, and in that we are using VLM plus rates and this MTP and all those things. And you can see some numbers over there on my right. You can see some charts here. Pretty clear, showing that the model is performing pretty good when compared CPU versus GPU, or as a model itself as a whole. So what did we learn? We learned few interesting stuff. If the data size is smaller itself, like let's say under 500k lines, right, then we are not seeing a lot much difference between CPU versus GPU. So what we wanted to do was to have an auto routing system where if the based on the data set question and query, the model decides whether to route to CPU or GPU based on what it's doing. So that's how it's done. And what are we thinking next? So as I told you, we want to have like the dashboards and charts and all. Right now the main model is doing it, but they are not so aesthetic enough. So what we wanted to do is, I have made like a new library itself, which is called Dataviz, which can generate HTML dashboards without any CSS or anything. It can just name a theme and get it out. So we I wanted to fine tune a model and add that as a sub agent to this, but due to the time constraint, I was able to just train the model. I was not able to complete the find attaching as a sub agent part. But as you can see, the model is ready, the data set links and all these things on my right. You can check them as well, and if you have any feedbacks on them also, you can let me know. Coming to the um, our product or the hackathon project itself, you can see it looks pretty good. And here, first of all, you can pick the data sets as well. You can pick of and out of any four. I have picked the look e-commerce data set, a public BigQuery data set from Google, and you can upload your files as well. That's completely fine. You can see a demo of the data set here to understand what and how it is working out. Then coming up next, you can ask your question here. Here I have asked revenue region by region, and ask here are some pre-built questions such that you don't need to write on your own, but you still can customize them. You can see the model tried 8 times. In the blue dot indicates that it's done, and it was able to complete the answer in 8 turn. It tried to calculate all the regions numbers, and it saved them, and it presented as a summary itself in the end. You can see the difference as well. And coming up next, like, you can see the code as well. So that's how this project works. I would be happy to hear any feedback on this, and any advices you want to give it to me, how to improve it, and all such things. Thank you for listening till the end. Thank you so much.